Problem name is find pivot index. Let's understand the problem. So array is given to us 1 7 3 6 5 6. Let me give index to it 0 1 2 3 4 5. So the question is saying find the pivot index. So what is the pivot index? Pivot index is that index whose left sum and right sum are equal. So suppose if I will check for index 3, the left sum is this is the left sum and this is the right sum. So if I am adding all the elements 7 plus 3 10, 10 plus 1 11, and here the right sum is 5 plus 6 11. So here right sum and left sum are equal. So index 3 is the pivot index. So how we can solve it? So initially I will solve it with brute force. So let me create a table and I will keep it left sum, right sum and index here 1 2 3 4 5. Okay, so I will put index here, left sum and right sum. I will start my iteration here. So for index 0 there is nothing on the left side, so left sum will be 0, and this is for index 0. And to find the right sum I need to add all these elements. So 7 plus 3 10, 10 plus 6 16, 16 plus 5 21, 21 plus 6 27. So it will be 27. So we can see that left sum is not equal to right sum. 0 is not equal to 27. So index 0 is not the pivot index. So we will move to right index. We will move to next index. Okay, now I will find the left sum for index 1. So on the left side there is only 1. So left sum will be 1. And this is for index 1. And to find the right sum I need to add all these elements. So 3 plus 6 9, 9 plus 5 14, 14 plus 6 20. So the right sum is 20. And we can see 20 is not equal to 1. So index 1 is not the pivot index. So we will move to next index. So now I will find the left sum for index 2. So I need to add all these elements to find the left sum for index 2. So 7 plus 1 8. So left sum is 8. And what is the right sum? I need to add these elements. So 6 plus 5 11, 11 plus 6 17. So right sum is 17. So we can see here 8 and 17 are not equal. So even index 2 is not a pivot index. So I will move to next index. So I will now find the left sum for index 3. So I need to add all these elements. So 1 plus 7 8, 8 plus 3 11. So left sum is 11. And I will find the right sum. So 5 plus 6 11. So right sum is also 11. So now we can see here left sum and right sum are equal. So 3 is the pivot index. And we will stop our iteration since we need the leftmost index. So 3 is the answer here. So what is the time complexity here? So for every index we are taking n-1 steps. So if you will take example of this index 3, we are going this way, we are taking this much steps, and we are taking this much steps, which is n-1. So for every index we are taking n-1 steps. So if I am ignoring -1, then it is n into n square. So time complexity is n square. And what is the space complexity? Space complexity will be order of 1 since we are not using any space. So now let's code it. So I will find the length of the array, then I will iterate the nums array I plus plus. Okay, I will create left sum equal to 0. Then I will iterate from k equal to 0 to k is less than I, k plus plus. And now I will do the left sum, nums of k. Similarly, I will do for the right sum. My k will start from I plus 1, k should be less than n, k plus plus. So right sum plus equal to nums of k, and if left sum is equal to right sum, we will return that index, and if there is no such index, we will return -1. So let's run it. So we got a compiler error, nums dot length. Okay, here it should be I should be less than nums dot length, or we have already n, so we can say it's n. So let's run it again. It got accepted. Let me submit it. So it got submitted. So this was our approach 1, and that is brute force. And we already saw that time complexity is order of n square and space complexity is order of 1. Now we will move to approach 2 and optimize the optimize the time complexity. So we have a array 173656. Let me give the index to it. 0, 1, 2, 3, 4, 5. So this is nums array. So what I will do here, I will create a prefix sum array and a suffix sum array. So I will keep adding elements and create a prefix sum array, and with opposite direction I will keep adding elements and will create a suffix array. So let me create it. So prefix sum. So it will be 1, 1 plus 7, 8, 8 plus 3, 11, 11 plus 6, 17, 17 plus 5, 22, 22 plus 6, 28. So our prefix sum array is created. Now I will create the suffix sum array. I will start from the last element, so it will be 6, 6 plus 5, 11, 11 plus 6, 17, 17 plus 3, 20, 20 plus 7, 27, and 27 plus 1, 28. So this is our suffix sum array. Now we will do the iteration. So for the first, for the element at 0th index, there is nothing on the left. So left is 0 and the right sum is 27. So 27 is not equal to 0. So 0 is not the pivot index. We will move to next index. For 7, the left sum is 1 and the right sum is 20, and they are not equal. So index 1 is not the pivot index. We will move to next index. For index 2, left sum is 8 and the right sum is 17, which is not equal. So 2 is not the pivot index. I will move to next index. So for index 3, 11 is the left sum and this 11 is the right sum. So both are equal. So 3 is the pivot index. We will stop our iteration here since we need the leftmost index. Okay. So now what is the time complexity here? So at max we will go, we will iterate n times. So the time complexity is order of n. And what is the space complexity? So we are taking n spaces in prefix sum and we are taking n spaces in suffix sum. So it is 2n, which is we can ignore 2, so it will be order of n. Space complexity is order of n. Now let's code it. So let me remove this and let me remove this. So I will find the length of the array. Okay, now I will create the prefix sum array. I will put the first element from the nums array. Then I will start iterating from the first element, from first index. Then it will become pfs of I equal to pfs of I minus 1 nums of I. Similarly, I will do for suffix sum. I will put the first element. I will start from the last index. So I'll put the last element from the nums array. And I will start from the n minus 2. I is greater than equal to 0. I minus minus. Suffix sum will be, it will be I plus 1 plus nums of I. Then I will iterate the nums array. Okay, then I will create the left sum, initialize it to 0 initially. Then if I is equal to 0, then our left sum will be 0 because there is nothing on the left side. Else left sum will be equal to prefix sum of I minus 1. For the right sum, if it is the last index, if I is equal to n minus 1, then right sum will be equal to 0 since there is nothing on the right side because it is the last index. Else right sum will be SFS of I plus 1. And if left sum is equal to right sum, then we will return that index. And if there is no index, if there is no such index, we will return minus 1. So let's run it. So it got accepted. Let me submit it. So it got submitted. So we already discussed what is the time complexity. So this was our approach to using prefix and suffix sum. And what is the time complexity? Time complexity is order of n and space complexity is order of n. So earlier in the order of n square approach, the space complexity was order of 1. So here we have improved the time complexity, but we got a space complexity of order of n. So let's optimize this space complexity with the approach 3. So we have a nums array 173656. Let me give the index to it 0, 1, 2, 3, 4, 5. So what I will do in this approach, I will update the input array only. I will update the input array to prefix sum array. Okay, so I will make it 1, then 1 plus 7 8, 8 plus 3 11, 11 plus 6 17, 17 plus 5 22, 22 plus 6 28. So I have updated the input array to prefix sum array. Okay, now I will start from this I. So if you want the left sum, suppose I want to know the left sum of ones, index 1, so this is the left index, this is the left sum. For index 2, the previous element is the left sum. For this index, previous value is the left sum. Okay, now then how I will find the right sum? To find the right sum, suppose I want to find the right sum for this. So what we can do, if in the from the total sum of all the elements, if I am subtracting these sum of elements, then we will get the sum of these elements. So what we can do, if I am suppose here, if I want the left sum of index 3, left sum of this element, then what we will do, see 28 is the sum of all the elements. I will subtract the 17 from 28 and I will get the right sum of index 3. So how we can achieve it? So suppose for any index, if I want to find the left sum, then what I will do? I will do nums of I minus 1. I will just check the previous element. And if I want the right sum, what I will do? I will do the nums of, I will take the last element, this one, and then the subtract it from the current element, nums of I. Okay, so this way we will do it. So let's do the iteration. So for 0 index, what is the left sum? Left sum is 0. And for the right sum, what I will do? I will just subtract 28 minus 1. So it is 27. So 27 is not equal to 1. So 0 index is not a pivot index. We will move to next index. For 7, for this index, 1 is the left sum. And what is the right sum? I will just do 28 minus 8. I will just subtract 28 with minus 8. So we will get 20. So 1 and 20 are not equal. So index 1 is not the pivot index. We will move to next index. So for the left, for index 2, 8 is the left sum. And what is the right sum? We can just subtract 11 from 28. So 28 minus 11, 17. And 17 and 8 are not equal. So index 2 is not a pivot index. We will move to next index. Okay, now for the index 3. What is the left sum? Left sum is 11. So left sum is 11. And what is the right sum for index 3? We need to subtract 11 from the 28. We will subtract 28 minus 11. So we will get from 28 minus, because we are taking for index 3. So we need to subtract 28. From 28 we need to subtract 17. So 28 minus 17 is 11. So left sum and right sum are now equal. So index 3 will be our answer. So we will stop iterating here, since we need the leftmost index. Okay. So now what is the time complexity here? So time complexity is simple. We will iterate n times at max. So it will be order of n. And what is the space complexity? Since we are updating the input array only, we are not using any extra space. So space complexity is order of 1. And this way we have optimized the space complexity. Now let's code it. I will remove this, and let me remove this also. Expand a little. Okay. Now I will take the array length. Okay. Now I will just update the input array to prefix sum. So what I will do, for int I equal to 1, I is less than n, I plus plus. I will write nums of I will be nums of I minus 1 plus nums of I. So our input array is updated to prefix sum array. Now I will iterate again the nums array. Okay, so now I will initialize left sum to 0. So if I is equal to 0, our left sum will be 0 because there is nothing on the left side. Else left sum will be equal to nums of just the previous element is the left sum. Similarly, for the right sum, I will initialize it to 0, and if I is equal to n minus 1, right sum will be equal to 0, else right sum will be equal to nums of, with the total sum, we will subtract the current element sum, nums of I, and at last we will compare left sum and right sum, and if it is equal we will return that index, and if there is no such index we will return -1 in the end. So let's run it. So it got accepted. So let me submit it. So it got submitted. So this was our approach 3, updating the input array to prefix sum. And what was the time complexity? We have already discussed it. It's order of n, and space complexity is order of 1, since we are not using any space because we are updating the input array. So I hope you have learned something. Thanks for watching.